Linux provides an integrated subsystem within the kernel that consists of a number of related components, and today we'll try and touch upon some of these and their benefits. Integrity Management Architecture, or IMA, was introduced with Linux kernel 2.6.30, and as part of overall Linux Integrity Subsystem, it's composed of multiple components including IMA, EVM, and a concept of trusted and encrypted keys. What an IMA, EVM, or IMA function module consists of: an ability to collect, that is, measure a file before it's even exists; store and attest, that is, add measurement to the kernel, and if measure that if a TPM hardware-based TPM is available, then sign it the PCR value, and appraise and protect. So that is to enforce local validation of measurement as a good value stored in an extended attribute of the file, as well as protect the file system or file security extended attributes against offline attacks. So in the demo today, we'll first create an image with integrity management enabled and boot it in fixed mode. Next, we'll create master and user keys and relabel the file system with security hash and signature the target file system. You can attest it using a hardware TPM if available, depending on the hardware. Then we will enable an system reboot in the enforce mode. Then the target file system, we'll try and temper it in an offline way, and to see if and try and demonstrate through the demo that how we will not only recognize the tempering attempt but also disallow an attempt of that nature. With that introduction, I request my colleague Navneet from the software architecture group at MontaVista to help show you Linux Integrity Management in action.
Fixed mode. The 81XX is booting now. System is booted. Now from the command line we can see that the IMA fixed mode has enabled. So we have to create some of the master key and user key, and we have to load that master key and user key with the IMA IDs and when the system is next rebooting. So first we have to create the master key and user key. So we are going to create, you can see the master key has been created and blob has been added. From there, so at the reboot time, this master key will be loaded with the IMA and EVM ID. Now the system is rebooting. As I explained, the need to boot in the fixed mode, that in fixed mode we are able to do the hash of the UID 0 file, that is the root files. Since the system is enabled IMA in the kernel configs as well, and system is also compiled with IMA and X590 certificates. So at the boot time the log message will show that the kernel is compiled with X590 IMA EVM certificates. So as we have seen that IMA EVM certificates are coming. Now since the system is rebooted and we already have automated the scripts, so the keys are already loaded. So now we have to relabel the file system and we have to apply the hash on the entire file system, and we have to signature the sbin files. So in this demo we are targeting the reboot file. So since it is hashed and signatured, so we are booted in the enforce mode. So now the system is booted in enforce mode, and now we can see that read, write and the execution permission. Since it is the online tampering, so first we are doing the writing. So writing is not permissible, so permission is denied. But it is online tampering, so we can able to read it, we can able to execute it, but we cannot write it. So this is first proof of concept that IMA EVM in online is tamper proof. Now we will do the offline tampering of the same file reboot. So to the offline tampering, we have to use the root file system or the media on which root file system is there. So we will reboot it, take out the media and do the offline tampering, and again reboot the system in force mode. So we are doing offline tampering. So for that we are rebooting it, and we can see since the reboot script, as I explained earlier, it should be readable and executable in online mode. So since I was in online mode, so that's why the reboot script is executed. Now you can see we have taken media out and we will do the offline tampering of the reboot files. You can see the reboot is a soft link file, so that file will be reboot the CSV in it will be changed. Here I am going to add, hey, I am a hacker. Trying to disturb reboot executable.
Somehow you got access to the
So somehow what we are trying to do, we are trying to take out our file system somehow in the media, or someone malicious person got the access of this system. They can modify it of the offline, but when the system will come again in the enforce mode, the system will not allow it to run. The reason is that when you will modify some of the content of the file, the hash will change, and in enforce mode, the system keeps the old hash with the signature. So since this file is the signature as well as hash and signature both, so what the system will do, system will check the same hash with that signature. So since hash is changed and the signature it cannot be changed, so both when will mismatch, it will not allow to run or execute or read. So this is what we can see. We cannot read it, we cannot write it, we cannot execute it. This is a proof of concept that in offline tampering, IMA EVM is keeping system tamper proof.